All right, now, can we have more than the fundamental or the first harmonic? And the answer is, well, certainly we can. And I'll demonstrate that second harmonic. Notice that the second harmonic has two humps. So it's going to be oscillating here and here, node here, and node here. And we'll have two spots, two antinodes, so these will be moving up and down like so. All right, now this is known as the second harmonic. Notice that we have two humps, second harmonic, or also known as the first overtone. So when we demonstrate that, let's take a look, and we know that L is equal to, well, let's see how much wave we have this time. So as we look at the wave itself, waves go up and down like so. Across the midline, we start here, goes to the center, and then back up again. Well, voila, looks like we've got ourselves one full wavelength this time, as twice as much as the top one. So let's just write that down. So the length of the vibrating string, or whatever it happens to be, could be a rubber band, could be a spring, could be a guitar string, could be a violin, whatever it is that you've plucked that string is under tension, it's going to start to create some of these harmonics. So we know that L is equal to lambda, and let's go back and review. We know that V is equal to F lambda. Lambda is going to be equal to V divided by F. So we can rewrite this formula once again. L is going to be equal to, instead of writing lambda, V divided by F. So if we look at that, we can see that we have a frequency and velocity version of this formula. Now, an interesting thing is happening here. If we look at the frequency here, let's make up a number. Let's say this is 100 hertz. How many humps, how many oscillations do we have here compared to the first one? And the answer is, well, we've got ourselves twice as many. So if I listen to this harmonic, it's going to be double the frequency. We're going to have 200 hertz. All right, and you're thinking to yourself, well, let's actually look at this. Can we actually see these standing waves again? So let me turn the camera around. I wish you luck in seeing this. Good luck to us. And let's turn it around and actually see if we can spot these waves as they're moving. I'll try to create a second harmonic by making two humps. So if you were actually here, I've showed you this in class, we can actually view this, and let's see what we got. So here we go. All right, so I'm actually demonstrating this. We've actually got two waves. Excuse me, we've got two humps here. We've got the node here, antinode, node, antinode there. And I'm not sure how clearly you can see this, but this is a great demonstration of a standing wave for a second harmonic. Now you're thinking to yourself, well, you know what, there's a first harmonic, a second harmonic. Is it possible to actually make third, fourth, fifth, sixth harmonic? And the answer is absolutely true. All right, so let's try and see how we're here to make a third harmonic and see if that is possible. So here goes nothing. And guess what? Indeedy doodles, there's the third harmonic, like so. So instead of having one hump, two humps, it's got three. So we created a third harmonic. All right, now let's settle that thing down. Ooh, settle down now, settle down now. All right, I wonder if we can make a fourth. Let's give it a try. All right, so we start back here again and put her into action. Let's see what we got. And indeedy doodles, I've got myself four harmonic here. It's getting a little crazy though, so I'm going to slow that down. Now, you think I got it in me to do a fifth harmonic? Heck no. Stop after class sometime, see if you can do five yourself. It's worth a shot. Maybe you're good.